Hello, hello. Welcome back. Here we go. Hopefully, you are keeping up with the homework assignments. Very important that you do that. Make sure you take notes as you watch these videos. Okay, here we go. 2.2. So last time in 2.1, we looked at how to plot points and we looked at how to find the midpoint. Okay, so here in 2.2, we're going to look at graphing linear equations into variables. Graphing linear equations in two variables. Again, if you have questions while you're watching these videos, feel free to message me through the Remind app. Okay, so linear equation. So let's take a look and see what that is. Okay, so standard form. Looks like this. AX plus BY equals C. So notice there are no exponents here. Okay, so, well, no exponents larger than 1. Okay, so, and note that some books require A, B, and C. To be integers. Meaning you can't have any fractions. So no fractions, no decimals. Okay, so if you do have fractions, we know how to clear fractions. We just multiply everything, even the non-fractions. We multiply all the fractions by the LCD of all the fractions that are in the equation. Okay. Some books will also require that A be a positive number. So if it's a -2 or something like that, you can multiply everything by negative and that will turn it into a positive number. Okay. All right, so let's determine solutions. We're going to look at this part because when we look at graphing linear equations, what we're doing is everybody thinks, oh, you're graphing a line, and you are, but what you're really doing is you are graphing the solutions to the equation. They just happen to form a line. Okay, so let's take a look. Example 1. Here's a question. Is the point -4, 5 a solution to this equation? Y equals -1/2 x plus 3. Don't be afraid of that fraction. Okay. The 3 is afraid. It won't show up. Come on, 3. Where are you? Okay. Okay. Sorry for that pause. My cat is standing on all of my things here. Okay. Move your tail. Okay. All right. So the way you determine whether or not this is a solution to the equation is by taking that x and y component. So remember, this point is an xy component. And we see here in this equation, we have an x and a y. So what we're going to do is we're going to take this xy component and substitute it in here for x and y, and we're going to see if it satisfies this equation. Okay, so substitute Okay, so let's have a look. So y is 5. Okay. So remember, this is x, this is y. All right, so y is 5. And we want to know, will this equal the other side? And the other side is -1/2 times x. X is -4 plus 3. Okay, so here 2 and -4 cancel out, leaving me with -2. So I get 5 equals -1 times -2, right? -1 times -2 is +2. And we see here that 5 does equal 5. So it does check. So the answer would be yes. -4, 5 is a solution to that equation. So if you were to graph that equation, -4, 5 would be a point that's on that line that you're probably familiar with. Okay. So if we ended up getting something like 5 equals 7, okay, so clearly 5 does not equal 7, and so we would say no, -4, 5 is not a solution. Okay. All right, let's take a look at another one. Is -3, 2. Is -3, 2 a solution to 3x plus 4y equals 18? Okay, I'm going to have you guys try this one on your own. So go ahead and try this. Is -3, 2 a solution to 3x plus 4y equals 18? Okay, so go ahead and try this one out. Hit the pause button and then come back to see if you got the same answer as I did. Okay, so we're going to go ahead and check. So we are going to take this x and y value and substitute it in here for this x and y value. All right, so 3 times -3 plus 4 times y equals 18. We don't know if it equals 18. We want to know, does it? Okay, so -9 plus 8 equals 18. -9 plus 8 is -1 equals 18. No, it doesn't. Okay, so no. All right, very good. Okay, so that's how you figure out if a point is a solution. Okay, so now let's take a look at graphing where we are actually graphing solutions. Okay. All right, so graphing. Okay, so let's take a look at this here. Let's go ahead and graph x plus y equals 5. And we're going to go ahead and use the table, okay, by making a table. Okay, so hopefully you've done this before where you make a table. And this table here is really a set of solutions to that equation, a set of points that satisfy that equation. And we can probably think of a bunch of points off the top of our heads without doing any work. But let's go ahead and choose some x values. You can choose x values or you can choose y values, but you can't choose an x and y value together. Like you can't go, oh, I'm going to choose 3, 7. Okay, so it doesn't work like that. You can choose only one of them. So you can either choose 3 and plug it in, or you can choose 7 and plug it in. Okay. So let's do a mix. Let's choose x. Okay, so let's choose an x value. I'm going to choose 2. Okay, you can choose any number you want. But why choose 1.798, right? When you don't have to. Okay, so 2. So what happens is you plug that 2 into the equation and you solve for y. Okay, so that's why we don't pick what we want for the 2. We can choose this x value, plug it in, and find out what we get for y. Okay, so 2 plus y equals 5. Solving for y, I'm going to subtract 2 on both sides, and I get y equals 3. Okay, I'm going to go ahead and put that in a different color. So that's the one that we found. Okay, we chose 2, and we found its y partner 3. Okay. All right. This time you can keep choosing x values, or you can mix it up and choose an x value, y value. You know, it doesn't matter which one you choose. All right. So to keep it interesting, this time I won't choose an x value, but I will choose a y value. So let me choose 1. Okay. So I'm choosing 1 for y. So I'm going to do my work over here. I don't know what x is, but I know y is 1. So now I'm going to solve for x. It's kind of obvious. So x equals 4. Okay. And again, I'm going to make this one in red so you know which one we chose. We chose the black ones, and we solved for the red values. Okay. 2 points is all you really need to make a line, but I always recommend 3, just in case one of those is wrong. Okay. All right. So we can choose an x value, or we can choose a y value. All right. So if I choose an x value this time, okay, I'm going to go ahead and choose. I can't choose 2 because it's already done, right? We already have a 2. We already have a 4. So you can't choose 2. You can't choose 4. I'm going to choose 1. Maybe some of you guys are at home are thinking 0, choose 0. Okay, in the future, we'll choose 0. All right, so 1 for x. I'm going to do my work over here. So I'm choosing 1 for x. I'm going to plug that in. 1 plus y equals 5. And I'm going to solve for y. So I'm going to subtract 1 here. I'm going to subtract 1 here. And I get y is equal to 4. Okay, so again, I'm going to do that in red. Okay, so now I have 3 points. Okay, so now I can go ahead and graph my equation. Okay, so I'll go ahead and do it right here. Here's my x-axis. Here's my y-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so we have this point, 2, 3. So 2 on the x, 2 on the x, and 3 on the y. So 1, 2, 1, 2, 3. So that's where my first point goes. Okay, the next point, 4, 1. So I'm going to go 4, 1, 2, 3, 4, 1. So my second point will go right there. And the reason why I like doing 3 points is because if you get a triangle, then you know something is wrong. But if you get all 3 points lined up in a nice straight line, 1, 4, then you know you got it right. Okay, 1, 4 is 1, 1, 2, 3, 4. Okay. And we see here that my 3 points line up nicely. Okay, I don't get a triangle. So that's how you graph by making a table. And again, what you're doing is you're plotting all the solutions to this equation. And there are infinitely many, right? I can plug in -1, and my answer for y would be 6. -1 plus 6 is 5, right? Any combination that makes 5 will work. So we have infinitely many solutions, which is why we put these arrows here, okay, to show that, oh, this goes on forever, and every point, every xy point that falls on this line is a solution to this equation, okay? All right, I want you guys to try this one. If you're still a little bit lost, then just follow along with me. But if you think you got it, then give it a try and then come back to see if your graph looks the same as mine. Okay? You and I might not have the same points, but our graph should be the same. Okay? Graph 3x minus 2y equals 8. Okay, so go ahead and give that a try. Hit the pause button and then come right back. Okay, so let's go ahead and make a table. Okay, so I'm going to choose a y value. I'm going to choose 1. Okay. And then the next point, I'm going to choose an x value, and I'll choose 0. Okay. And for my third point, I'll choose a y value, and I will choose 0. Okay. So these are my 3 values. Okay. So starting with the first one, y is 1. So I'm going to plug that into here, and I'm going to solve for x. So 3x minus 2 times 1 equals 8. So 3x minus 2 equals 8. Okay, now I'm going to solve for x. So I'm going to add 2. 3x equals 10. Divide both sides by 3. X equals, I'm going to turn this into a mixed number. Okay, so 3 goes into 10 3 times, which is 9. So I have a remainder of 1, and the denominator stays the same. Okay, so 3 1/3. All right, so there's my first point. All right, my next point. So I am going to choose 0. I chose 0 for x. Okay, so let's go ahead and work that out. 0 for x. So 3 times 0 minus 2y equals 8. 3 times 0 is 0. So that's gone. So negative 2y equals 8. Divide both sides by negative 2. And y equals negative 4. Okay, so let me do that in red. Okay, there we go. All right, very good. We have 2 points. Let's get a third point so that we can verify that all of the points are correct. Okay, so 0 for y. So 3x minus 2 times 0 equals 8. Again, 2 times 0 is gone. Okay, so we get 3x equals 8. Divide both sides by 3. And you should get x equals, again, I'm going to turn this into a mixed number. Okay, 3 goes into 8 twice. That's 6. So I have a remainder of 2, and the denominator stays the same. Okay, so here for my last point, I get 2 and 2 thirds. And the reason why I write them as mixed numbers is because it's easy to see that 2 and 2/3 is a number that's going to be between 2 and 3. Okay. Well, if I leave it as this 8/3, it's kind of hard to figure out where 8/3 is on a number line. Okay. All right. So let's go ahead and graph this. Okay. So I'll graph it right down here. All right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the first point, this is my x-axis, this is my y-axis. Okay, so 3 and 1/3, 1. So 3 and 1/3 is between 3 and 4. So I go 1, 2, 3, and 4 is over there. So I'm somewhere in between here, closer to 3 though. 3 and 1/3, 1. So I'm like right here. Okay. All right. 0, -4 is my second point. So 0 on the x-axis and then straight down to -4. So right here. And going for a third point to verify that everything is done correctly, 2 and 2/3. So 1, 2, that's 3. So 2 and 2/3 is somewhere in between here, between 2 and 3, but closer to 3. Okay. So like right around there. And 0. So right there. And we see that all 3 points do line up. So I'm pretty confident this was done correctly. Okay, so again, you might have different points, but it doesn't matter what points you guys choose, your graph should still look like this. If your graph is somewhere up here, or if your graph is going down like that, then it's not right. Okay, your points, you should see your points somewhere here on my line. Okay. Okay. Again, if you have any questions, make sure you message me. All right. So 0 over here. Using 0 is pretty easy to work with, the calculations, because it's nice. They cancel out right there, right? So we're going to take a look at using zeros. Those points actually have a name. They're called the intercepts. The intercepts, no matter what kind of an equation you're dealing with, whether you're dealing with a linear equation or an exponential equation, a log equation, a sine equation, any fancy equation, intercepts, the same. How you find them will be different, but what it is remains the same. Okay, so x-intercepts. Okay, so this is the point where the graph crosses the x-axis. Okay, you find by letting y equal 0. So you're just going to go ahead and plug 0 in for y. Okay, so here I'm going to just scroll up here. So over here, the y is 0. So this point right here, whenever the y is 0, that point is the x-intercept. Whenever you see y is 0, again, for any kind of equation, linear equation, a parabola, a sine cosine tangent equation, fancy equations. If you see y is 0, this point is the x-intercept. Okay, so that's how you find the x-intercept. You let y be 0. So you guys probably already found it for the previous problem. Okay, and then the y-intercept. This is the point where the graph crosses. Oh, did you just complete my sentence at home? The y-axis. Yes, you are right. Okay. And you find this by letting, what do you think it is? You find this by letting, very good. Did you say x equals 0? You are correct. Okay, so you let x be 0 and you solve for y, and that will give you the y-intercept. So if we look up here, when the x is 0, that y value is the y-intercept. Okay, so we found the x and y-intercept here, or at least I did. Okay, so again, when x is 0, that y value is the y-intercept. When you have 0 here, that's x value is the x-intercept. Okay. So let's go ahead and graph by intercepts, where we only find 2 points, and those 2 points are the x and y intercepts. Okay. So it's similar to the previous problem, but instead of doing 3 points, we're just going to do 2. Okay. So we'll go ahead and graph x plus 2y equals -3. Okay, and I'm going to go ahead and make my table. And again, instead of choosing 3 points, we're going to choose 2 points. We're going to choose 1 point where the x is 0, so I'll be plugging in to find the y pair. And then I'm going to choose 0 for y, plug that in, and solve for its x. Okay. All right, so let's do this one first. So x is 0, so let's plug that in. Okay, so that's just gone. Okay, so we get 2y equals -3. And then we're going to divide both sides by 2. So y is equal to -3/2. Okay, but again, that's an improper fraction. Whenever the numerator, the top number, is larger, you can always turn it into a mixed fraction. So 2 goes into 3 once with a remainder of 1. So that remainder goes on top. Denominator stays the same. Okay, so let me go ahead and change this to red. Okay, so we get -1.5. All right, good. All right, so let's do the other one. Okay, 0 for y, right? So for this one, now 0 is y. Okay, so we're going to plug 0 in for y. And I'm going to solve for x. Okay, so that's gone. So I get x equals -3. Well, that was easy. Okay, so let's go ahead and choose this red one again. And we get -3. Okay, so those are our 2 intercepts. So this one right here, that's the y value. So this one is the y-intercept. Okay, and the one down below over here, that's an x value. This one is the x-intercept. So right here, this one's your y-intercept. And this one here is your x-intercept. Okay. All right, so let's go ahead and graph this. X, Y, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have 0, -1.5. So 0, 0 on the X, -1.5. So 1.5. So you're like right there. Okay. And then -3, 0. So 1, 2, 3, 0. And your intercepts should be right on the axes. Okay. All right. And there we go. Okay, so that's how you graph using intercepts. Maybe some of you guys know like a shortcut that you learned before. We're going to be looking at that in the next couple of sections. Okay, but I want to go over one more, well, two special case lines. Okay, so if you notice, most of our lines here were like at an angle. So maybe they went like this, or maybe they went like this, right? Okay, but they're kind of at an angle. Okay, so what we're going to look at here are two special case lines. Okay, so we're going to look at number one, the vertical line. Okay, where x equals some number, and that's your equation. That would be your equation of your line. Okay, x equals like 2. That's the equation for the line. Okay, so we're going to look at that. Okay, and so here's an example. So maybe you have x equals 3 and they say graph this equation, x equals 3. Okay, so then this is going to be a vertical line. 1, 2, 3, 4. This is going to be a vertical line that passes right through x equals 3. Okay, so it passes through x equals 3 and it's a vertical line. So that's a special case line. And the other one is the horizontal line. And that one looks like this here, the equation. It's just going to be y equals a number. Okay. So you'll see here, you only have an x and no y. So down here, you're only going to have a y and no x. Okay. So you don't have to make a table because, I mean, you don't have anything really to plug into and solve for, right? Because here you always had an x and a y, right? Here, you won't have both. You'll only have an x or you'll only have a y. Okay. So maybe you have y equals -2 and you're asked to graph that. Okay. So again, whenever you only have one of the variables, it's one of these special case lines, horizontal or vertical. Okay. So this is the horizontal line at -2. Okay. So here's my x-axis, y-axis, 1, 2, 3. Okay. So it's the horizontal line that passes through -2. Okay, so that is it for 2.2. Again, if you have any questions, please email me or text me through the Remind app. And please keep up with your homework. Take notes whenever you watch these videos. Take screenshots and email them to me, or take pictures of your screen with your phone and text it to me. Okay, but make sure you get the help you need. All right. I'll see you guys next time.